moving on to part 2, we're going to talk about tangents to circles. Okay, so the first thing we're going to do is talk about the tangent line to circle theorem. So if you have your circle, like so, and here's the center, and you have a tangent to this circle, then exactly one radius can be drawn to the point of tangency, and that will create a 90-degree angle. Okay? So let's take this a step further. Let's say now that we know that this is a line of tangency, so we have our radius drawn to the tangent to make our right angle, and we know that this is our radius here, and we're going to actually draw another line from the center of our circle, and we're going to connect it to our point of tangency. Okay, so now we have formed a right triangle. And you can connect it anywhere to the point of tangency. It just has to be a straight line. So let's say we have some values here. Let's say that this radius is actually 12. And this part of the line of tangency is actually going to be 35. And this part here, oh, it's not drawn to scale, is going to be 25. How do we find this missing section right here? Well, we know that this is another radius, right? And we know our radius over here is 12, so that means this has to be 12. Therefore, our whole section is going to be 37. And if you apply Pythagorean theorem, and we can because this is a right triangle, and we know that this leg, or this right here, is our hypotenuse, because this is the leg of the triangle that is opposite from our right angle. So this is our hypotenuse, which makes this a leg and this a leg. So we know we can write the Pythagorean theorem and check ourselves and make sure everything is correct. So we would have 12 squared plus 35 squared equals our hypotenuse squared, which is 37 squared. And if you work all that out, type it in your calculator, you will see that it's actually true. It works. Okay, let's do another example. All right, let's draw a circle again. Okay, and we're going to have our line of tangency here. Okay, and we're going to draw our radius. I'm actually going to draw it in red. I'm going to draw our radius to our point of tangency, and we know that creates our right angle. Then we're going to start at our center point of our circle, and we're going to draw a line that connects our center point to our line of tangency. Now we have a right triangle. So what if we were given that this is 50, and here we know that this is R, and we know that this part here is also a radius. Radius, radius. And the length of our line of tangency is actually 80. So what is the radius of this circle? You have enough information here to solve for the radius of this circle. You can use Pythagorean theorem. Figure out what your legs and your hypotenuse are. So we know this is a leg, this is a leg, and across from our right angle, we have hypotenuse. So we have a squared plus b squared equals c squared. Our a squared is going to be r. So radius squared, r squared. Our b squared is going to be 80 squared. And it's going to equal our c squared. Well, we have a little bit of a predicament here because we don't know the full length, the full value of this line. We have 50 for this part and R for this part. So the way you would write that would be just to add them together. So you have R plus 50, R plus 50. And it's squared because this is your C. This whole thing right here is your C, and you're squaring it. Okay, so let's solve. We have R squared plus 80 squared, which is going to be 6,400 equals, now, how do we square something in parentheses? We just went over this. You're going to write it out, and then you're going to FOIL it. R plus 50 times R plus 50. Okay, let's FOIL this. We have R squared, that's our first. I'm going to write it up here, FOIL. Our outside is going to be plus 50R. Our inside will be plus 50R, and our last will be 50 times 50, 2,500. Okay, let's combine all of our like terms here. R squared equals 6,400. I'm sorry, R squared plus 6,400 equals R squared plus 100R plus 2,500. Okay? Now, let's subtract R squared from this side. So this essentially cancels out. And now let's subtract 2,500. So we're left with 100R equals 3,900. Now, all you have to do is divide by 100, and you get 39 equals R. So your radius here is 39. So this side, your hypotenuse, would be 39 plus 50. It would be 89 in length. And your radius here, your leg here, would be 39. Okay, moving on. Our next theorem is called external tangent congruence theorem. So if you have a circle and we have a tangent line coming up, well, say we have a common external point, and we, wow, this is not a good start, and we have a tangent coming off of this, and we have another tangent right here. So each tangent line touches a circle in one place, but they originate from the same point. Or maybe they keep going. But what we're talking about is what originates from this external point all the way to where it touches the circle on both sides. What this theorem says is that two tangents that originate from the same point are, in fact, congruent. So, for example, if you were given that this value, length of this line is 28, and this one is 3x plus 4, and you were asked to solve for x, you could do that by setting them equal to each other, because this tangent, from where it touches the circle, where it intersects the circle, to the original point over here, is congruent. They're congruent. So you could say 28 equals 3x plus 4, and then you would have subtract the 4, 24 equals 3x, divide by 3, x equals 8. So you can solve for x. You can solve for the length of lines of tangency by seeing that they're congruent to each other. All right. So, what if you had one that looks like this? Here's your circle, and here is your line of tangency. Here's our original point, and we're going to go ahead and draw radiuses. Oops, I messed that one up. To our points of tangency. And this one here is x squared, and this one is 9. How would you solve for x? You're going to do it the same way. Set them equal to each other. X squared equals 9. Take the square root of both sides. X equals 3. All right. Moving on. That's it for 10.1. So let's start into 10.2 now. I'll put this on part 3.